Welcome to the Crazy Hat Chemist. So good morning, good afternoon, and good evening. So hopefully you're doing well. All right. So electrons and atoms worksheet, only single one. Before you begin this video, make sure that you have watched my lecture on electrons and atoms collection. Make sure that you have also watched the periodic table and the quantum numbers video, or quantum numbers and periodic table video. That's essential. We have gone all the way through problem number 35. And so that's actually on the back side of the second piece of paper. So we have actually finished up problem number 35. So what do we have to do now? We have to finish this little baby up here. So let's see if we can do this. So what we got here is the following. Let me see if I can zoom in on here and get it properly done. We need to start off with problem number 36. Okay, so problem number 36, it says the following, 36 through 45, that is, what elements have the following electron configurations? All right, so what we have to do is look at our periodic table. And we're going to find the elements that have these following electron configurations. So here we go. Here's our periodic table. We have been used to using this one frequently, I believe. In fact, we have it in this format right here. Absolutely. Okay, we've been using this one quite a bit, and we'll just keep on using this one. So our first electron configuration that's given is right here. It says helium 2s2 and 2p3. 2s2, 2p3. So really what we need is our periodic table. I'll zoom in on here just a little bit. It says that we're using helium. That's the noble gas helium. And then it is a 2s2. These are s-type orbitals. So here's what we're going to do. We're going to take our periodic table and we're going to write all over it and do a couple of things here so that it makes sense for you. All right, so here we go. Principal quantum number 1, 2, 3, 4, 5, 6, and 7. This goes with the S's and the P's. The D's are one less than the period. So this is a 3D, a 4D, a 5D, and a 6D. The F's are one less than the D's, or two less than the period. So this is a 4F and a 5F. Let's see here. Sorry about this. Just a little bit congested this morning. And it is morning where I'm at right now at this moment in time. Maybe it's not where you are, but it is morning where I'm at. All right, so these are S-type orbitals right here in the pink. And then we have the P-type orbitals right here in the orange. And the ones that are not yet named are also P's. If you can see that, not yet named, those are also in the P's. These are the P-type orbitals. And that's in the orange. And then in the blue are the D-type orbitals. Okey-doke, perfect. D-type orbitals. And let's go for yellow. In the yellow are the F-type orbitals. F-type orbitals. F-type orbitals. That is S is in sharp, P is in principal, D is in diffuse, F is in fundamental. All right, so our first problem here, let's see if I can come back to that. The first problem was the electron configuration of helium 2s2, 2p3. What element is this? There's helium 2s1, 2, 2p1, 2, 3. So that would be neon. Sorry, not neon. That would be nitrogen. Nitrogen, and that's element number 7. Perfect. Okay, let me zoom in on here and so that you can see that clearly. So this is nitrogen. Our next one is number 37. That's xenon 6s2, 4f14, and 5d4. So let's see if we can find that element here. So zooming on out here so that you can see my whole entire periodic table. Let's see if we can, there we go. And we're going to zoom this on up here just a little bit. Yeah, that will make more sense. All right, so this next one, I have xenon. So that's xenon, that's element number 54. Then thereafter that, I have 6s2, that's a 6, and that's an S, and that's 1, 2. And then it's 4f14, so it's 4f14, so it's all of these Fs. Then it is 5d, 1, 2, 3, 4. So that will be tungsten, element number 74. So that's W, and that's element number 74 for tungsten. Perfect. All right, our next one here is number 38. That's neon, 3s2, 3p4. So neon, let's zoom this down. There we go. Neon. And then we have 3s, 3s, 1, 2, and then 3p. And that would be 1, 2, 3, 4. So that would be sulfur element number 16. Sulfur element number 16, just like that. Perfect. All right, we're going to do our next one, number 39, in just a second. All right, so let's carry on here for problem number 39. That's krypton and a 5s1. So let's figure out where that is. That is krypton right here. That's 36. And then it is a 5s and a 1. Boom, that's rubidium. That's element number 37. So RB number 37. All right, fantastic. Our next one, number 40, is argon, 4s2, 3d10. So that is argon. That's right here. And then it is 4s2. That's 4s and 1, 2. Then it's 3d, 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's zinc element number 30. So Zn element number 30. Okay. Our next one is problem number 41. That's krypton, 5s2, 4d2. So krypton, that's right here. 5s1, 2, and then 4d1, 2. Zirconium number 40. And that's Zr number 40. Awesome. Fantastic. This next one, number 42, is argon, 4s2, 3d4. That's argon, 4s2, 3d, 1, 2, 3, 4. That's element number 24, chromium. So that's number 24, Cr. All right, cool. Next one, number 43, is xenon, 6s2, 4f6, 5d1. So let's do this very carefully. We're going to move this on up there just a little bit. So it was xenon, that's xenon, 6s1, 2. And then after that, it is a 5d1. That's element number 57. Now I'm going to have to do 58. That's a 4f. 4f, 1, 2, 3, 4, 5, 6. Europium number 63. So EU number 63. Perfect. All right, the next one here is going to be number 44. That's radon, 7s2, 63, and 5f14. Again, that's radon, 7s2, 63, 5f14. So that's radon, 7s12, 6d1. Okay, and then 5f14, so 5f 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then it was a 6d3, so 6d1, which we already counted, 2 and 3, and that is element number 105. So dB number 105, dB number 105. The next one is number 45. That's radon, 7s2, 61, and 5f7. So radon, 7s2. That's 1, 2, 61. That's right there. And then it is a 5f. 1, 2, 3, 4, 5, 6, 7. That's element number 96. That's curium. That's Cm. That's element number 96, I believe. 96. All right, fantastic. So I am going to zoom in on just these set here, just so that you can see the answers of these as just a rekindling of everything. So this is the noble gas notation, electron configuration of all these, and we are trying to identify what element this is for that electron configuration. I have the atomic number and then the element symbol. That is almost partially the, or it is partially the standard nuclear notation without the mass, which that's not necessary. All right, so the next set of problems, I'm going to scroll this on up here. I've got 2 segments here to do. What we're going to do is we have our element. And again, what really identifies our element so very nicely is the atomic number. And I'm just highlighting that there. That's the atomic number. Okay, so we're trying to write out the electron configuration for this element, beryllium, or oxygen, or sodium, for example. And then the next question right below it is to write the valence and core electrons in the parentheses. So let's see if we can complete this task in not all too much time. All right. All right, so here we go. So we're going to write out the electron configuration for beryllium, first of all. And so I'm going to have to zoom on out just a little bit on this and make a nice big periodic table that fills in most of the space. So here we go. Perfect. Put a couple of weights on here so that we can make sure that we don't move our papers around. All right, so here we go. So we're doing element number 4. So we're going to write out the electron configuration using the noble gas notation of this. So we're going to go up 1 period, slam it far to the right. That's helium. And then it will be 2, S1 to S2. So I'm going to write out the electron configuration for this beryllium here. And that is helium. And then it is 2s2, just like that. That is kind of small, so I'm going to zoom in on that so that you can see that. That's helium 2s2. All right. We're also going to write out the valence electrons and the core electrons. So valence electrons. Valence electrons, I'm going to label this on top of my periodic table. This is 1 for everything in this column. This is 2. This is 3, 4, 5, 6, 7, and 8, excluding helium. And then everything that is, I call in the boot. This is my own made up here. So if you are in the boot, how many valence electrons do you have? 2. So, all right. So valence electrons are labeled as such, and then we need to know the mathematical equation here. It's really simple. Total electrons is equal to the valence plus the core. So what we're trying to do is figure out the total electrons for beryllium is 4. So that's a 4. The valence electrons is 2. So how many core electrons? So it's the 4 minus the 2. That would have corresponded 2. All right. So let's write this down for this as well. So here we go. I'm going to zoom in on this so you can see this. There are 2 valence electrons for beryllium and there are 2 core electrons. So just making sure here, this is valence. And let me see if you can see my highlighting mark here. There's valence, and that's this first number. And then there are core electrons. Then there are core electrons, just like that right there. All right. The next one is going to be oxygens. That's at atomic number 8. Okay, so I'm going to find oxygen on my periodic table here, and that is right here. I'm going to go up 1 period, slam it to the far right. That's helium. So I'm going to write down helium. This is using my noble gas notation. So helium in brackets. And then I'm going to write everything after helium until I get to oxygen. So here is helium, then it will be a 2s12, and then it will be 2p, since this is in the same horizontal section. So it's a 2p, 1, 2, 3, 4. All right. So let's see if we can zoom in on that and write that down. So that would be a 2s2 and a 2p4. Okay, how many valence electrons are there in oxygen? So valence electrons for oxygen, 6. How many total electrons? 8. So 8 minus 6 is 2. So there are 2 core. So we're going to zoom in on this right here. And how many valence electrons for oxygen? 6. How many core? That's the total number of electrons, 8 minus the 6. That would be 2. So again, I'll just highlight this. This is valence in the orange and core in the yellow. Perfect. All right, good. All right, so our next element here is sodium. And so let's zoom on out. We'll use our periodic table here, and we are going to find sodium on our periodic table. So here's sodium, it's element number 11. We're going to go up one period, slam it to the far right. That will be neon. And then it is a 3s1, and that will be the electron configuration for sodium. So it is neon, neon, and then a 3s1, just like that. All right. So how many valence electrons in sodium? Well, that's pretty simple. That's element number 11, and we're going to go up one up at the top here, and there's 1 valence electron. There's a total of 11 electrons, so it's 11 minus 1. That's 10 core. So we're going to write that down. There's 1 valence electron, and then there are 10 core, just like that. All right, the next element here is silicon. That's element number 14. So let's find that on our periodic table. Okay, that's element number 14. That is right here, element number 14, that's silicon. So we're going to go up one period, slam it to the far right, find our noble gas. Our noble gas is going to be neon. We're going to write that down. So that will be neon. And then we will count after that to find silicon. So that neon is element number 10. So we find number 11. That's a 3s12. Then it's a 3p12. So 3s2, 3p2. 3s2, 3p2. I'll zoom in on that so you can see that clearly. So neon 3s2, 3p2. Silicon has a total number of 14 electrons, and we need to find out how many valence electrons are in silicon. Silicon has 4 valence electrons, so it's 14 minus 4, that's 10 core. So we're going to write that down as well. So how many valence electrons? 4, and there are 10 core electrons. I'm hoping that you're seeing a pattern here. Okay, again, I'm just going to highlight the valence electrons in orange and the core electrons in yellow. Okay, all right, so core electrons are in yellow and valence electrons are in orange, and the atomic number is, of course, the total number of electrons. That's equal to the valence plus the core. All right. Perfect. Our next element that we're going to be doing is scandium. That is element number 21. So I'm going to look on my periodic table and I'm going to find element number 21. That's right here, scandium. I'm going to go up one period, slam it to the far right. That's going to be argon. And then it is a 4s12, 3d1. So I'll write that down for scandium. That's going to be argon. So that's AR, and that's a 4s2, 3d1. Okay, fantastic. Now to get the valence and the core. So scandium ends in a D, so it's in the boot. So if it's in the boot, how many valence electrons? 2 valence electrons. There's a total of 21 electrons. So let's zoom in on here. We're going to write down our 2 valence electrons. And there are a total of 21 electrons. So it's 21 minus 2, that's 19 core. All right. Next element here is gallium, and that's element number 31. 31, let's find element number 31. Element number 31 is right here. That's element number 31. We're going to go up one period, slam it to the far right. That's argon. That's our noble gas that we're going to be using here. Okay, so we're going to end with gallium. We got argon, our noble gas. We're going to do 4s12, 3d 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then a 4p1. So let's write this down here. We've got argon, 4s2, 3d10, and 4p1. Perfect. Gallium has how many valence electrons? Gallium has 3 valence electrons. There's a total of 31 electrons. So let's write this down. There are 3 valence electrons. There's a total of 31 electrons. So it's 31 minus the 3, and I'm going to get 28 for the number of core electrons in gallium. Our next one is rubidium. That is element number 37. So number 37, let's zoom on out so we can find element number 37. Element number 37 is right here, rubidium. I'm looking for that. So I'm going to go up one period, slam it to the far right. That's going to be krypton, and then 5s, 5s1. Simple. Krypton with 5s1. So Kr, and that's a 5s1. That's the electron configuration for rubidium. Let's find out the valence and the core. So valence electrons, rubidium is in group 1, so it has 1 valence electron, and there's a total of 37 total electrons. So let's see here. We've got 1 valence electron. There are 37 total, so it's 37 minus 1. That would be 36 core electrons. Perfect. The next element that we're doing is silver, hi-ho silver. That is element number 47. I'm going to find 47 on our periodic table. That is right here. I'm going to go up one period, slam it to the far right, and find my noble gas. That's krypton. So I'm going to write krypton and then 5s12, 4d 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's krypton. Kr in brackets, and then it's 5s2, 4d9. So 5s2, 4d9. Now I'm going to make a little caveat here on this, and that is I am writing the predicted electron configurations. These are not necessarily the actual electron configurations. These are the predicted electron configurations. So make sure that you make a note of that. So, okay. We need to get the number of valence and core electrons here for silver. So silver is within the boot. It ends in a D or an F, so there are 2 valence electrons. So 2 valence electrons, and it has 47 total electrons. So 2 valence electrons, 47 total, so that would be 45 core electrons for silver. Perfect. Next one is tin, which is element number 50. So I'm going to find 50 on my periodic table here, and here we go. Here's element number 50. That's tin. I'm going to go up one period. I'm going to slam it to the far right. I'm going to have krypton. Krypton with 5s12, 4d1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then a 5p12. So krypton, and let's see if we can zoom in on this so you can see this. So krypton and like that, and then 5s2, 4d10, and 5p2. And the number of, the number of valence electrons in tin is 4. There's 4 right there. And so there are 4 total valence electrons in krypton. The total number of electrons is 50. 50 minus 4, that would be 46 core electrons. Beautiful. Next one is iodine. That's element number 53. So I'm going to find number 53 on my periodic table. That's element number 53 right there. I'm going to go up one period and slam it to the far right. I'm going to find my noble gas of krypton. Okay, then it is a 5s12, 4d 1 2 3 4 5 6 7 8 9 10, and then a 5p 1 2 3 4 5. Okay, so krypton and then the rest. Here we go. Krypton, and then that's in brackets. That's 5s2, 4d10, and a 5p5. Okay, now what we're going to do is we are going to write out the number or discover the number of valence electrons, which is 7 for iodine. Okay, and it has 53 total electrons. So let's zoom in on here. So 7 valence electrons, and there are 53 total electrons. So 53 minus 7, that would be 46 core. All right, we're halfway done with this segment here. I'm just gonna let you see those electron configurations. Just keep it there for just a moment, okay? Remember, you are watching the Crazy Hat Chemist. Yeah, this is the place that you find all of your chemistry needs met, at least. That is all your correct chemistry needs. You want to learn how chemistry really is, then this is your place to learn the basics of chemistry so that you can be successful in college or whatever you want to do in chemistry. Chemistry is a fantastic, wonderful field. I highly recommend it. It's a great major in college, and it allows you to do lots of different productive careers, whether it's in engineering or medicine or biochemistry. Any one of those fields will allow you to have a job, keep a job, move anywhere you want to in the world, and also the world will be your oyster. So anyways, okay, here we go. We're going to continue on. We got another half to do. Okay, our next one is element number 57. That's lanthanum. So we're going to find that on our periodic table. Element number 57. So let's zoom on out here. So there is number 57 right here, lanthanum. We're going to go up one period, slam it to the far right. That will give us xenon as our noble gas right there. So xenon, and then 6s12, and then 5d1. That's it. So xenon, and let me zoom in on here for you. 6s2 and 5d1. Perfect. All right, that's the electron configuration for lanthanum. Now we need to figure out the number of valence electrons. Well, lanthanum is in the boot, so it has 2 valence electrons. So 2 valence electrons, and the total number of electrons is 57. So we're going to take 57 minus 2, and we're going to get 55 core electrons for lanthanum. Praseodymium. I'm not sure if I'm pronouncing that correctly, but it's pretty good. So we got 59 for element number 59. So let's find element number 59 on our periodic table. Okay, and that is right here. There's element number 59 right there. Perfect. So element number 59. And we're going to, so element number 59 really belongs in this segment right here. So this right there, it belongs right there, just like that. So we're really here. We're going to go up one period, slam it to the far right. That's going to be xenon, and then it's 6s2, 5d1, and then 4f2. All right. So here we go. That's xenon, and 6s2, 5d1, and 4f, I think it was 2. Yes, 4f2. Perfect. So praseodymium is in the boot. Let's see here. You can see that this is, of course, in the boot. So how many valence electrons? 2. Okay, there's a total of 59, so that would be 57 core. So that is 2 valence electrons, and 59 minus 2, that would be 57 core electrons. Perfect. All right. Next one is neodymium. That is element number 60. So if you have one of those super strong magnets, it's probably made of this element right here. So we're going to find element number 60. That's the next element. Okay. Again, that's in this segment. We're going to go up one period, slam it to the far right. That's xenon, 6s12, 5d1. Then it's 4f, 1, 2, and 3. Okay. So let's write down this electron configuration for neodymium. That is xenon, and that is 6s2, 5d1, and 4f3. It's also in the boot, so there are two valence electrons, and 16 minus 2, that would be 58 for electrons. Perfect. Tantalum, that's element number 73. So let's find number 73 on our periodic table, and that is right here. Okay, so we're going to go up one period, slam it to the far right. That is going to be xenon. Okay, xenon, and then it says 6s12, 5d1, 4f, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then it's back to that 5d1 that we had, 5d2, and 5d3. Notice that this is, we are just walking one number at a time on the periodic table. We're doing 55, 56, 57, 58, 59, 60, 61, 2, 3, 4, 5, 6, 7, 8, 9, 70, 71. Then we're going back to the D's with the 72. We already did 5d1. This is 5d2 and 5d3. Okay. We starting at 55 because we actually truly started at xenon with the noble gas of 54. So let's all write this down here. So it's going to be xenon and a 6s2, 5d, and I believe it was a 5d3. That's right, 5d3, and 4f and 14. Okay. No, that's a little bit small and cramped, but hopefully you can still see that. And the number of valence electrons in this, well, it's in the boot, and there are a total of 73, so that would be 73 minus 2, that's 71. The next element is the next element, which is tungsten. And so let's see if we can do that one. So here is tungsten. And we're going to zoom on out, and we're going to find that one. So it's up one period, slam it to the far right. That is going to be xenon. It's going to be a 6 and an S and a 1, 2, 5d1. Then it's 4f14. Then we're back to that 5d1, 5d2, 5d3, 5d4. Okay, perfect. So let's write that down. So that is going to be xenon, 6s2, 5d4, 4f, and 14. Tungsten is in the boot. There are two valence electrons. 74 minus 2 is 72 core electrons. Next one is lead. That's number 82. So number 82, zooming on out. Here is element number 82. I'm going to go up one period, slam it to the far right. I'm back to xenon again. So I got xenon, 6s12, 5d1. Then it's 4f14. Then it's 5d1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it is 6p2. That's a whole lot there. So let's write that down for lead. Whoops, here we go. We're going to zoom on in here so we can see this. So that is xenon, 6s2, 5d10, 4f14, and 6p2. Cool. And let's see, how many valence electrons in lead? That's 4 valence electrons in lead. And so that's 4 valence electrons in lead. The total number of electrons is 82. So 82 minus 4, that would be 78. Okay, we're getting closer here, folks, most certainly. The next element is number 92, and that is uranium. Uranium right here. largest quantum number with the most, with the naturally occurring, highest naturally occurring element there is. Everything thereafter is man-made, pretty much. So element number 92. Number 92 fits in the periodic table right here. I'm going to go up one period, slam it to the far right. That's Rn, radon. So radon, baby. Here we go. 7s12, 6d1, 5f123. So radon, that's Rn in brackets. And then it is a 7s2, 7s2, and it is a 6d1, and it's a 5f, what was that, 5f3, 5f123, yes, 5f3. Perfect, just like that. Uranium is in the boot. So it has total number of 92 minus 2, that's 90 core electrons. All right, next one is element number 94, plutonium. Everybody likes to have plutonium hanging around at their house. Just kidding. Element number 94, plutonium. Remember, it's in this section right here. So we are going to go up one period, slam it to the far right. That's going to be radon. 7s12, 6d1, 5f1, 2, 3, 4, and 5. Okay. 1, 2, 3, 4, 5. All right, so zooming on in here on this one here, we've got Rn, we've got 7s2, 6d1, and 5f5. There's total number of 2 valence electrons and then 92 core electrons for plutonium. Plutonium. The next one is seaborgium, and that's element 106. The only element named after someone that was alive while that element was named. What an honor. There it is, element number 106. We're going to go up one period, slam it to the far right. That's radon. And so we're going to get 7s12, 6d1, 5f14. And then we're back to our 61, 62, 63, 64, and there we are. Okay, so radon, 7s2, 6d4, and 5f14. It has 2 valence electrons because it's in the boot, so that would be 104 core electrons for seaborgium. Copernicium, that's element number 112, is our last one of this subset, and that's what we're going to do. Element 112, that's right here. We're going to go up one period, slam it to the far right. That's radon, and then it's 7s12, 6d1, 5f14, 62, 3, 4, 5, 6, 7, 8, 9, and 10. It's the last one of this. So let's zoom on in. So that is Rn. That's 7s2, 6d10, and 5f14. This element here is in the boot, so it has 2 total valence electrons, and 112 minus 2, that would be 110 core. All right, I'm just going to leave it here on this here just a moment here so you can see all that and verify and validate those. I'm going to flatten this out, and I'm going to just show you all of these here now. Let's zoom on out so you can see all of these answers. Okay. Now I'm going to do one other thing. Okay, so I've already done the valence electrons by using the periodic table, right? Okay, these are the valence electrons. In orange are the valence electrons. Okay, I'm going to show you an alternate way. If you already have the electron configuration and you want to get the valence electrons, it's the largest principal quantum number, SNP, of the same largest principal quantum number. So let's see if we can simulate that or obtain this in a different number here. Largest principal quantum number is a 2, and it's S, so 2 valence electrons. Okay. Largest principal quantum number is a 2. It's S and P. So you're going to sum those up, that 2 and that 4, and that equals that 6. Largest principal quantum number is a 3, and it's an S. That's a 1. Largest principal quantum number is a 3, and there's an S and a P. I'm going to add those up. That's 2 plus 2, that's 4. Largest principal quantum number is a 4, 2 valence electrons. Largest principal quantum number is a 4, so it's 2 plus that 1, and that's 3. Largest principal quantum number is a 5, and it's an S, that's 1. Largest principal quantum number is a 5, and there are 2. Largest principal quantum number is a 5. There are 2 5s. There's a 5s and a 5p. I'm going to add those up, and that's 2 plus 2, that's 4. Largest principal quantum number is a 5, and that's 2 valence electrons here, and plus that 5, that's 7. Hopefully you're seeing that these add up correctly. Largest principal quantum number is a 6, and that's 2 valence electrons. Largest principal quantum number is a 6, 2 valence electrons. Largest principal quantum number 6, 2. Largest principal quantum number 6, 2. Largest principal quantum number of a 6, 2 valence electrons. The largest principal quantum number of a 6, there are 2 6s, and we're going to add those up. That's 2 plus 2, that's 4. Largest principal quantum number, a 7. Largest principal quantum number, 7, 7, and a 7. So you should see that I've been able to obtain the valence electrons by using the electron configuration in addition to looking at the periodic table. 2 different methods, both of them work. They're both equally valid. Give them a try both times. All right, here we go. We're going to keep on going here. We are almost done with this worksheet. We have effectively 2 more problems, but many problems within those problems. Okay, so we got problem number 67. Number 67, it says, give the element symbol for the following electron configurations. It says 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d4. So, while I have this periodic table right here like this, let's see if I can zoom on out, and let's see here. I'm going to have to do this here. All right. So I've got this periodic table right here. And right now we are looking at just the electron configuration and figuring out what that element is. Okay. So here we go. Let's see if we can figure this one out. Oh yeah. A little bit of, there we go. Perfect. You got my paperweights here. So our first one is 1s12. Then it is a 2s2, 2p6, 3s2, 3p6, 4s2, and 3d4. 1, 2, 3, 4. Chromium. So this first one is chromium. Cr, that's element number 24. There, just like that. Okay. I'm going to zoom in on that so that you can clearly see that. So we've done that electron configuration. I've walked you through it on the periodic table, and I've found that element. Let's go for the next one. We've got all this to do. Oh my, oh my. Sounds like a party. Okay. So sadly, these are not in the noble gas electron configuration. So I'm going to zoom on out and you're going to follow along. That's 1s12. Okay. Then it is 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, and 5d5, but it also has 4f14 and 5d1, 2, 3, 4, 5. RE number 75. RE number 75. And again, I'm going to zoom in on that so you can see that. Okay. All right. Next one is very similar to the last one, except it ends in a 6p2. That's the key on this one here. as well as most of these. Okay, and so we're going to end at a 6p2. 6p12, that's going to be lead. That's going to be 82. So that is PB, and that's element 82. All right, perfect. Next one is krypton 4d1 5s2. So zooming on out, we've got krypton 5s2 4d1. Bingo. That's yttrium 139. Why 39? Not why 39, like why is it 39? Right, it's element number 39. Next one is radon 5f261 7s2. So let's find that here. So that is radon. And then it is 7s2, 61 and 5f12, PA number 91. PA number 91. Perfect. All right, next one. 1s2, 2s2, 2p6, 3s1. So I'm looking for 3s1. Where's 3s1? There's 3s1. That is sodium number 11. Everything is filled in prior to that. And A number 11. All right, next one. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. So I'm looking for 3d7. 3d7. That's a 3d1, 2, 3, 4, 5, 6, 7. Cobalt number 27. CO 27. Perfect. The next one. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 3d10, 5p3, 5p3, 5p1, 2, 3, SB, antimony number 51. SB number 51. Perfecto. This last one here, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 5d10, 4f14, and 6p3, 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 6p1, 2, 3. Oh my gosh, bismuth. Like, it's none of your bismuth. Element number 83, bismuth, element number 83. All right, perfect. All right, next and final problem here, folks. We are gonna do it. That is correct. We are gonna make it. I know we're gonna make it. And we are gonna finish off this. We're gonna finish off this video. Here we go. Let's see here. Let's zoom on out just a little bit so we can see this entire problem here, and a little bit of self-advertisement. I am the Crazy Hat Chemist. That's right, folks. Please like and subscribe if you are actually learning anything in chemistry from me. Said, what is or are the maximum number of electrons in the following energy levels? Consider all shells and subshells. So N of 1. So I'm going to do this two different ways, and hopefully you'll get the idea. So how many ones are there? There's 1, 1. That is there a 1s orbital? Yes. How many electrons can you fit in s orbitals? 2. Is there a 1p? No, there is not. That is, if you look on that periodic table, and this is 1s, but there's no 1p right here. It's missing. So there's no 1p. There's actually no 1p. So I'm going to add these electrons up, and that's 2. 2. Okay. 2's. When n is 2, is there a 2s? Yes, there is a 2s. Is there a 2p? Yes, there's a 2p. Is there a 2d? Nope, there is not a 2d. How many electrons can you fit in the s's? 2. How many electrons can you fit in the p's? 6. You're going to add those up. You get 8. That's 8. All right. Next one. 3's. Is there a 3s? Yes. Is there a 3p? Yes. Is there a 3d? Yes. Is there a 3f? That is a no. Nope. How many electrons can you fit in S's? 2. How many in P's? 6. How many in D's? 10. You're going to add those up, and that would be 18. Okay, 4s. Okay, the 4s. So is there a 4s? Yes, there is. Is there a 4p? Yes, there is. Is there a 4d? Yes, there is. Is there a 4f? Most certainly, yes, there is, but there is no 4g. That's a no. Okay, and this is really important that you understand this part here. Okay, so we're going to do 2, 6, 10, and 14. We're going to add those numbers up. That's 32, just like that. Is there a 5s? Yes. Is there a 5p? Is there a 5d? Is there a 5f? Yes. Is there a 5g? Most certainly. Is there a 5 GH? No, there is not. So that's 2, 6, 10, 14, 18. Add them up, that's 50. Okay. So these go 18 and 32 and 50 for these numbers. That is one possibility. Here is another one, 2n squared. So when n is 1, 1 squared is 1 times 2, that's 2. Check. When n is 2, 2 squared is 4 times 2, that's 8. Check. When n is 3, 3 squared is 9. 9 times 2 is 18. Check. When n is 4, 4 squared is 16 times 2 is 32. Check. When n is 5, 5 squared is 25 times 2 is 50. Check. Fantastic. We've done it 2 different ways. And if you have any questions as to how you get these number of electrons in these orbitals, then here's another way of looking at it. How many electrons are in the S's? Well, 1, 2, 1, 2, 1, 2. How many in the P's? 6, 6, 6, 6. How many in the D's? 10, 10, 10, 10. Just like that. Okay. Does that make sense? All right. It should make sense. How many in the F's? 14, 14. Here's another way of looking at this. Okay. There are the number of orbitals are associated with the boxes and the types of orbitals. So 1, 3, 5, 7, 9, 11. Okay. That's S, P, D, F, G, H, etc. It keeps on going. Okay. All right. By the way, I am the Crazy Hat Chemist, and hopefully you have learned some great chemistry here today. And I hope you have a fantastic day. I'm signing off with this video here and ending it with the series. The next one is going to be periodic trends, so I can't wait for that one. Please like and subscribe to my videos if you are learning something. I really truly appreciate that. Spread the word, spread it to all your friends, families, and pets. Thank you very much. Bye for now.